Researcher at Datadog, where he specializes in offensive AWS security. He's known for finding multiple zero-day vulnerabilities in AWS services and regularly publishing on new attack techniques. The title of Nick's talk is Kicking in the Door to the Cloud, Exploiting Cloud Provider Vulnerabilities for Initial Access. Please give a warm welcome for Nick.
Hey everyone, thank you so much for being here. Welcome to my talk on exploiting AWS vulnerabilities for initial access. Mike just gave me a great introduction, so I don't want to try and follow it up. Just two things to note. If you've seen me before at most recently DEF CON main stage or Black Hat, this is the same talk. DEF CON is a limited time, so I definitely don't want to waste yours, or we could also free up some space perhaps for folks still online. So again, if you recognize me from recent events, this is the same talk. Second thing, I don't know about you, my eyes are not very good anymore, and we're going to be looking at a bunch of IEM policies so that we can exploit them. They tend to be kind of small and hard to show on a slide. So that QR code will take you to this slide deck so that you can follow along on your phone or mobile device of your choosing. With all that out of the way, listen, breaking into AWS accounts is a topic that is near and dear to my heart, and I'm sure it is for many of you as well. But I think if we're being completely honest with ourselves, the traditional methods of gaining access to AWS environments are boring. If we were to poll the audience for real-world cloud breaches and security incidents, I guarantee 95% of scenarios will fall into one of three categories. They were either caused by a leaked access key, an exposed S3 bucket, or an exploited EC2 instance. These are the stereotypical ways that adversaries gain access to AWS environments and resources. And to be clear, these are very real risks that we do have to contend with, but this is Cloud Village. This is nothing you haven't seen before, and again, these are boring. What we're gonna be doing instead is kicking in the door to the cloud, breaking into US East 1, and exploiting vulnerabilities in AWS services themselves, particularly by taking advantage of pre-existing trust. What do I mean by that? Well, a common design pattern within AWS is to have IEM roles in your account that have a trust relationship back to some AWS service. This enables that service to take action and perform functionality in your account. What we're going to be doing today is finding vulnerabilities in those AWS services so we can hijack that trust relationship, gain access to victim AWS accounts, so that from there, we can access resources, escalate privileges, move laterally, and more. In this session, we're going to describe how trust is established between IEM roles and AWS services. We're then going to dive deep on two vulnerabilities, as well as a general misconfiguration that will allow us to hijack those roles. And finally, we're going to talk prevention options. In the absolute worst case scenario of an attacker having a cross-tenant AWS zero-day, like we'll demonstrate in this talk, what options do we have to potentially mitigate that attack vector? Worth noting, most of the vulnerabilities we're going to be talking about today have since been fixed by AWS. So think of this more from the perspective of what can we learn from these vulnerabilities that we can apply to better attack or defend cloud environments. With that out of the way, to get us started on the topic of abusing pre-existing trust, we should probably talk how that trust is established. In AWS, every IEM role has a role trust policy. And this policy determines who or what is permitted to assume a role. There are a number of identities that can be permitted via trust policy, IEM users, roles, AWS organizations, and more. But where I think this is particularly interesting is when we authorize an AWS service to have the ability to assume a role. To sort of demonstrate this, we're going to be using Lambda as an example. What you may be able to see there on the right side of the slide is the default trust policy associated with the role used by Lambda. If you create a Lambda function today, this is the role trust policy that would be automatically created for you. And what it says is that we're going to allow the Lambda service to assume this role. The way this works in principle is every time your Lambda function runs, the Lambda service assumes that role in your account and does whatever it is you want it to do. Now, this behavior is really interesting because if we think about it, I already said this is the default trust policy. So theoretically, the overwhelming majority of Lambda functions use this very same policy. And if we read it, it just authorizes the Lambda service. It's not tied to someone's specific account. So could we get a little sneaky and create a Lambda function in our account, but point to or reference a role in someone else's? preferably one that we don't have legitimate access to. Could we cause this Lambda service to assume the role in the victim account and access resources or do things that are beneficial for us? Well, the good news or bad news, depending on your perspective, is there is something that's supposed to stop this. And that's called pass role. Anytime you provide an IEM role to an AWS service, you are interacting with pass role. One of the core rules of which is you can only, quoting, you can only use the pass role permission to pass an IAM role to a service that shares the same AWS account. If you try to pass a role outside of your account, well, you'll almost always get an error. Cross-account pass role is not allowed. Now, this is a very important security boundary in AWS because without it, theoretically, we could just arbitrarily assume role into anybody's account and access all the resources associated with those roles. So this is going to be the target of the first part of our talk today, finding a vulnerability in the pass role implementation that would allow us to weaponize an AWS service against a role that trusts it, so that from there, we can access all the resources associated with it. So this first vulnerability is a confused deputy vuln in AWS AppSync. If you're not familiar with AppSync, AppSync is a managed GraphQL service offered by AWS. It allows you to quickly and scalably build GraphQL APIs. The way that it works is very similar to what I described with Lambda. You create an AppSync API, automatically as a part of your data source, it'll create a role for you that has a trust relationship back to the AppSync service. Then, every time your AppSync API runs, the AppSync service assumes that role and does whatever it is it's supposed to do. And also, like Lambda, if you try to pass a role outside of your account, you get the error message, cross-account pass role is not allowed. Now, this is Cloud Village. I'm sure many of you are already trying to think of ways to bypass this control. Perhaps some weird encoding schemes, maybe something like HTTP request smuggling, or maybe something even more exotic. These are all great ideas, and I strongly encourage you to try them in your own time, but we actually found a much simpler approach to get past this control through the power of SpongeBob memes. See, under normal circumstances, the AWS API is case sensitive, and what we mean by that is it expects parameters in a very particular casing. If you don't meet that expectation, you'll almost always get an error. So as a 100% unrelated API, just to demonstrate this behavior, here we're performing secrets manager create secret. And that API expects a name parameter with a capital N. If you pass it in that format, 200 okay, you created a secret, everything worked normally. But if we were to change the casing on that parameter in any way, in this particular case, we made it all uppercase, we pass that to the API, well, it gets mad. 400 bad request, member must not be null. The reason for this is we didn't actually pass the parameter it was looking for. It might be the right alphabetical characters, but it's not what it's specifically looking for, and so it rightfully so throws an error. While this may sound like a weirdly specific thing to point out and almost obvious, the reason I am is because by comparison, AppSync was an oddity. It was not case sensitive. You could pass arbitrary parameters in mixed casing and it would take it totally fine. Presumably somewhere on the back end, it was normalizing these values in some way. Now, the parameter you would use to pass a role to the AppSync service was service role ARN, capital R, capital A. If you try to pass a role outside of your account, once again, cross-account pass role is not allowed. But if you change the casing on that parameter in any way, in this case, we've put it all to lowercase, and we try to pass a role outside of our AWS account. For some unknown reason, whatever filtering, allow listing, or checking that was supposed to occur either didn't happen at all or completely failed. And so by changing that casing on a parameter, we were able to break a major security boundary in AWS through SpongeBob memes. With this capability, we now could pass arbitrary IAM role ARNs to the AppSync service for it to try and assume. To put this another way, any legitimate role in any AWS account that used AppSync was now a target for us that we could assume into and access whatever resources were associated with it. This is an example of a cross-service confused deputy attack, where a lower privilege entity, us, was able to trick or coerce a higher privilege entity, the AppSync service, to do something on our behalf. And in this scenario, that was to assume a role in a victim account and carry out whatever API operation we asked it to perform. That's how we're able to do things like, oh, shoot, Really quick, I did want to stress, the thing that makes this possible, the thing that enables this attack, is this pre-existing trust between that IAM role and the AppSync service. Because the role trusts AppSync, and because we are weaponizing AppSync against it, this is the trust avenue that we are taking advantage of to assume that role and perform that API call. That's for a practical example of how we'd exploit this as an adversary. We would create our own attacker control AppSync API, configure it, set the schema, decide what API call we wanted to make, and so on. We would then perform that pass role bypass to specify the victim role we want to assume, and then under normal circumstances, the AppSync service would assume the role in our account and do whatever. But because of this vulnerability, it assumes the role in the victim account and performs whatever we want it to perform. Whatever identity policies are associated with that role are all available for us to take advantage of. So for instance, we can do something like this in this screenshot, where we're dumping the contents of a DynamoDB table cross-tenant in AWS by invoking the DynamoDB scan operation. If you'd like to learn more about this vulnerability, AWS did release a security bulletin for it. And in addition, we have a blog post with a ton of additional information on conducting confused deputy attacks in AWS and how we think about approaching this type of research. Next, before we dive into our second vulnerability, we need to learn a few things about assume role with web identity. Up until this point, we've been learning about plain assume role, which is typically used for AWS to AWS role assumption. Now, while assume role is great, it does have a little bit of a limitation, and that is that it requires the entity doing the role assumption to originate from AWS. And unfortunately, there's a variety of use cases in which you might want to have someone from outside your cloud have the ability to assume a role. What do? Well, one option is to use assume role with web identity. The idea here is that you sort of offload the responsibility of authenticating or authorizing a user to an identity provider of your choosing. This can be a private identity provider, one that you or your organization own and maintain, or it can be a public identity provider. Think Facebook, Google, Amazon, GitHub, and things like that. Your external identities, whether they are human or machine, interact with this identity provider to generate a token. That token is then passed into the assume role with web identity call to authorize you to assume a role in an account. Now, before we dive into this next point, I really want to stress, assume role with web identity is a general design pattern. It's used by a number of technologies, some native to AWS and some completely external. We're going to be focusing in on GitHub Actions because it is a common use case, but I really want to stress, we're not isolated to just GitHub. A variety of services will exhibit this exact same behavior. So, like I said before, every IAM role has a role trust policy. And what you see here on the slide is the most basic, bare bones, simple trust policy you could possibly have when using assume role with web identity. And what it allows you to do, what it says is that we're going to allow the GitHub identity provider to assume role with web identity. And that's a really scary thought, because if we think about it, the GitHub identity provider is public. It's global in a sense. There's nothing stopping someone from creating their own GitHub account, creating their own GitHub action to generate a token signed by that very same identity provider, passing that in to the assume role with web identity call, and now they can assume a role in your account. If you had this trust policy on a role in your account, anybody in the world could have assumed it. That is why anytime you use assume role with web identity, with an identity provider that is, in a sense, public or global, you need to have a condition which restricts who specifically is permitted to assume that role. Again, assume role with web identity is a general design pattern. The specific condition you will need will differ depending on what service you're using and what options you have. To continue using GitHub Actions as an example, you need to restrict either the GitHub organization that is permitted to assume it or the GitHub repo. If you're a heavy AWS user, strongly encourage you to audit your roles for this misconfiguration, as it can allow basically anybody the ability to assume roles in your account, which I think we can all agree is not good. The good news, though, to this situation is AWS actually did something about it. Last year, this particular attack was very much in vogue. A number of security researchers, including my own colleague Christoph, identified this misconfiguration and sounded the alarm about it. If you want to learn more about the GitHub Action specific scenario, we have a blog post with some more details, and that QR code will take you there. Now, in response to this raised awareness, AWS did something good. They made it so that this once optional condition is now mandatory. You can no longer create a trust policy tied to the GitHub identity provider that does not include a condition. And so that's great. That theoretically closes the loophole for any new roles. Fantastic. But it's really important to stress, they only did that for GitHub Actions. Any of the other services that are similarly affected by this very same misconfiguration were/are still vulnerable. So again, strongly encourage you to audit your roles. What I'd like to do is dive a little bit deeper into one of those services because it led to something very interesting. The service I'd like to take a look at is Amazon Cognito. If you're not familiar, Cognito is essentially like a sign-in as a service offering from AWS. It allows you to securely store user credentials, but if you don't want to deal with like hashing, salting, password reset flows, and all that jazz, you can pay Amazon a fee. They'll take care of that for you. One of the core features of Cognito is something called an identity pool, which is a resource you can create in your account that you can use to authorize external users generating IAM credentials in your account. So for example, if you're building a web app, you want your users to be able to upload files to S3 or perhaps invoke an API gateway using IAM auth. What you could do is create a Cognito identity pool, allow your external users to interact with it to generate tokens, then using those on assume role of web identity, they assume the role in your account and do whatever it is you need them to do. The good news about Cognito is it seems the developers foresaw the very same attack we did with GitHub Actions. In particular, they by default, out of the box, include a condition which restricts which identity pool can assume the role. And so this effectively mitigates the attack. If that condition is not present for any reason, well, once again, anybody can assume that role. And we're going to be talking about some reasons why it wasn't present in just a little bit. So the way we would do this, very similar to what we described with GitHub Actions. The only implementation detail is rather than some public identity provider, we can actually just bring our own identity pool. That would give us the token we need. We could pass that into assume role with web identity, and we could assume that role. So for our purposes, we're going to refer to this as the variant 1 vulnerable trust policy. Why variant 1? Because there's a variant 2 as well. You might have noticed, if you have very good vision, that by default on the Cognito trust policy, there is a second condition, and that is the AMR, or the authentication methods references. This value can be authenticated or unauthenticated. And you might be wondering, could we have assumed a role if that condition was present? Well, yeah, absolutely. All that condition's doing is checking if you are authenticated to an identity pool, not that you are authenticated to a specific identity pool. And since we can bring our own identity pool, we can configure it however we like. We can add that authentication component or get rid of it, depending on what is needed to satisfy that condition. You might have noticed I called this a misconfiguration. That's because it totally is. Everything we've talked about so far with assume role with web identity, the GitHub Action stuff, Cognito stuff, any of the other services that are affected by this very same thing, these are all misconfigurations. Had you suffered a breach, incident, or other security issue, well, unfortunately, that would have been your responsibility as a part of the AWS shared responsibility model. And so at this point, you're probably thinking, well, Nick, I was promised a second vuln. You're calling this a misconfiguration. What gives? Well, this is where things get weird, and we dive into our second vulnerability, the AWS Amplify service exposing IAM roles to take over. See, earlier this year, when we noticed this capability in Cognito, one of the first questions we had was, okay, cool, I wonder how common this misconfiguration is. And because it could be used for initial access, literally just assume rolling into people's accounts, we wanted to know if we could use publicly available data to find vulnerable roles and notify their owners so it could be fixed. To do this, we used a tool called SourceGraph. One of the free features of which is essentially like a Google search for public GitHub repos. We wrote a regular expression to find IAM role ARNs, threw it into SourceGraph, we got back results, deduplicated them, removed like clearly placeholder ARNs with like account IDs of all 1 digit and incrementing digits, things like that. That left us with a little over 8,000 results. We then tried to assume each role twice, once authenticated, once unauthenticated. We let our automation run, and pretty much immediately it was clear something was horribly wrong. Remember, this was across all of public GitHub, across teams, organizations, individuals, and companies. So why was it then that the overwhelming majority of roles that we found to be vulnerable all had this weirdly specific naming convention? What you may or may not be able to see on the slide are real roles that we found in the wild that were vulnerable that we have slightly tweaked the names of so as to respect the anonymity of their owners. Now, what made these roles so strange was that they all ended in either auth role or unauth role. And additionally, they appeared to have a timestamp dating back to 2018 or 2019, or they had a 6-digit integer. Presumably, these were the newer ones. To make things even weirder, we actually found 3 roles that belonged to AWS themselves. And so it wasn't clear what was going on that was making these roles vulnerable. Using SourceGraph, we were able to find the name of the file where these roles were being found. And again, the overwhelming majority were found in a file called teamproviderinfo.json. And this ultimately led us to the culprit that was exposing IAM roles such that anyone in the world can assume them. Turns out, it was AWS Amplify. Normally, when we're talking about a misconfiguration, we're talking about a mistake, a misunderstanding, developers moving a little bit too quickly, or not realizing that something is as exposed as it actually is. This is a rare circumstance in which an AWS service itself exposed IAM roles such that anyone in the world can assume them. And unfortunately, they didn't just do it once. They actually did it twice. If you're not familiar with Amplify, the way Amplify works is that it's a framework for building web and mobile applications. Essentially what it does is it will obfuscate a lot of the underlying infrastructure. So if you're building a web app, you want users to be able to log in, create accounts, change the password, and so on. Your developers don't even need to know what Cognito is. By using Amplify, Amplify will go in, create those Cognito resources, configure them, and so on. Key emphasis, Amplify configures them. What's neat about this vulnerability, and why it's personally one of my favorites, is this is a rare circumstance where we're actually able to know not only how this vulnerability was introduced, but when. And that's because the Amplify CLI is open source. And by digging through the commit history, we can actually see how and when these vulnerabilities were introduced. Now, I do want to be respectful for time, since we did start a little bit late. To quickly summarize this, the variant 2 issue was introduced in July of 2018. A little over a year later, on August 8th, 2019, they sort of fixed the issue, seemingly unintentionally. Essentially what occurred here was they seemingly unintentionally made a fix so that no future roles would be misconfigured. However, any that had already been created were still vulnerable, and we could still assume them like we did in 2024. In July of 2020, the variant 1 vulnerable trust policy was introduced to the Amplify CLI and Studio. We disclosed this in January, and by February and April, AWS introduced comprehensive fixes to both of these variants. In particular, they went a little bit above and beyond what they did with GitHub. They did the same thing where you can no longer create trust policies that are vulnerable to this misconfiguration. The API will actually reject it. But also, they made changes to STS itself to prevent you from being able to assume a vulnerable role. So even if you were an Amplify user, you had a variant 1 or 2 role in your account, someone from a different AWS account cannot assume that role. If you'd like to learn more about this vulnerability and dive a little bit deeper in some of the things I had to sort of skip over here, definitely check out the security bulletin from AWS, as well as we have a blog post with a ton of additional detail, information, and more. Now, speaking of picking things for time, we'll actually make this a little bit of a choose your own adventure. Would you rather learn how you can prevent confused deputy attacks like the one that I showed, or would you rather learn how you can actually still today exploit the Amplify vuln? Which would you prefer? Show of hands for the Amplify vuln, keep it down if you'd rather do the defense side. Okay. All right, I'm seeing more hands down, so I guess we'll go with the defense side. Just know you can actually still exploit this like today. It is more difficult. It does require an additional misconfigured resource, but the Amplify vuln is still there. That QR code, depending on how quickly you can scan it, will walk you through step-by-step a Hacking the Cloud article for both authenticated and unauthenticated scenarios. But let's talk a little bit about what we can do to prevent cross-tenant attacks in AWS. Some neat controls that AWS offers us are condition keys that can restrict either the ARN, the account, or the org that is permitted to assume a role. The way that we would do this is we would attach these as conditions on our role trust policies. Now, definitely note, these are not included by default. If you created an instance profile tomorrow, this wouldn't be automatically attached. So you do have to manually apply these to each role you want to protect, and most crucially, ensure that the service is compatible with them. From some nominal testing, it appears that EC2, Lambda, and AppSync all work totally fine. Again, definitely strongly encourage you to test this before you try pushing to production. Using AWS source account as an example, the way that this works is you set this condition on the role trust policy, and an adversary who has a cross-tenant confused deputy vulnerability would be blocked because the account they're originating from does not match that in the condition. And what's super cool about this is we actually got to test this in real life. Back when the AppSync vulnerability was present and we were able to break into accounts, we were able to test setting the condition on that role trust policy to limit which account was permitted to assume a role. And indeed, it did successfully block us. So even in that absolute worst case scenario of someone having a cross-tenant zero-day in AWS, these condition keys may be able to protect your resources. The other reason I like these is from a defense in depth perspective. You know, if pass role says under no circumstance should someone be able to assume a role cross-tenant in AWS, well, great. Listen, we broke that with SpongeBob memes, so the next time somebody figures that out or finds an even more exotic way to do it, let's have an additional layer of defense to block these types of attacks. So quickly in conclusion, we took a look today at how confused deputy attacks can weaponize cloud services against us. We took a look at assume role with web identity and a very dangerous misconfiguration that could cause your roles to be assumable by anyone in the world. Again, strongly encourage you to audit your roles. It's a very easy mistake to make. Amazon made it twice. And then we also took a look at how we could use conditions to defend ourselves from confused deputy attacks in AWS. If you enjoyed this talk, you can find more of our research at securityLabs.datadoghq.com. If you have any questions, feel free to come find me after or reach out on social media. My name is Nick Frechette. Thank you all so much.